Hey, hello, everybody. I'm sure the audio works. Okay. Hello, hello. Okay. Hello, everybody. My name is Jose. This is Marcelina, and we'll be your presenters today for the intermediate Python workshop. I know most of y'all have already logged in and see the spider login. If you're not there, it's fine. We're just gonna do some preemptive intro so you have time to load it up. Okay. Don't worry about it.
And then, so for those that are on virtual, your login to Spider will be through my FSU VLab. And those instructions are in the interest email. So if you want to follow along online, that's where all your stuff will be. So the setup is a little bit different, but we'll catch up with you guys when we start talking about what's happening in Spider.
Okay. Now, before we start, we just want to talk about what we're going to do in the workshop for the next hour and a half. Okay, so what is the structure of the workshop itself? So first, we're just going to talk a bit. So the goal of this workshop is to get you used to, one, importing modules into Python, second, importing CSV data, and then producing something with that data. Okay, so we'll do a mock project throughout the next hour and a half that will accomplish that. The other one is that we'll be using multiple files to do this and importing functions between files. So the only knowledge we expect you to have is be able to do functions in Python. Okay, have imported a module before, and we'll basically build from there. Okay, so that's the basic knowledge that we expect you to have coming in. We'll do an intro to what is Open On Demand, which is the tool that you have opened to log on to Spider. And then an intro on how the Spider interface looks. So how does the development environment look? How do you interact with it? Then we'll move on to actually making the Python files and explaining what we're trying to accomplish with the project. And at the end, we'll just work the actual code. Okay, so that is basically how it's gonna shape out today. If you have any questions, please raise your hand. We'll go forward from there. But yeah, just now we'll tell you what the project is all about.
Yeah, and so also for anyone online, if you have questions, we do have a moderator. We have Alex Townsend moderating questions online. So when we field questions, we'll also ask him if there are any online questions. So for the overall project, we're going to start off with a CSV of world demographics by country. And this is what the CSV looks like, and it's already going to be populated in your home directory if you have a workshop account. And the end goal is to produce two plots, a pie chart of all the countries with their share of global population, and then a top 10 most populous countries as a bar chart. And I think that's really it. So that's our like A to B, and then we'll go through on each iterative step as we go through. But so first we'll talk about setting up Spider. Yeah. Okay. So this is the Open On Demand dashboard. You can either go to interactive apps or the little tiny like double squares and then click on Spider. This will bring you up to the parameters. And then we already have this set up as a as its like running application. But currently, the only things that you would have to change if you're logging in person is the Slurm account and then the number of hours. And then once you click launch, it'll slot you over to My Interactive Apps, which is the tiny squares on the side. Once it starts running, you'll have the Launch Spider button right here. When you click on that, it should open to Spider. It will take a little bit of time to load in, but once that's set up, it should look very similar to this. Ours is slightly zoomed in for readability purposes. And yeah, so what else? Oh, okay. So for those that have not used Open On Demand before, if you exit out of this tab, you can just go back to that My Interactive Sessions screen here and then click Launch Spider as long as your time remaining has not expired. So that's very helpful if like you're outside of this workshop, if you're using Open On Demand and you want to like move across campus at some point or like work at a different spot, you can actually completely turn off your computer and then turn it back on, come back to this page, and launch it if you still have time remaining. Which is really helpful because sometimes when you're running stuff on your computer, you can't shut it off or move anywhere, or else you risk like losing your data. So to jump into what is Spider, it's a development environment that allows you to run Python. And it's slightly different from how we did it in the Python Bootcamp where we're using Jupyter, just because this has a lot more flexibility and usage in terms of developing like multi-file projects. So on your left-hand side, you have your Python files, and like these in general, you can just open any files that you have. So for example, we can open the CSV file. If we click on File, Open, and then it should be 2024_populations.csv. And if we open that, we get a giant crazy CSV file, but it then shows in that same window. And then we can click back over to temp.py, which automatically shows up and has a little bit of documentation there. So on our right-hand side, we have two different windows. The top half is, it's in itself has multiple different tabs. The one that automatically opens is the help. And we'll mostly be using the plots, but it is helpful to know that the variable explorer will tell you what variables you run Python code with and like what they equal, if you run it, whether it's within the file or within the little Python console window on the bottom half of that right side. And then then I guess before we move on, the files tab on that top half will basically show that directory that you're currently working in, and then all the files in there. So that way you don't have to open up the new or open to see what files you're working on in that directory. So that bottom half of that right side is a Python console. And basically you can just do a line by line Python instruction. So for example, we can do a = 5. And then once we click enter, we run it as Python code. And if you go back to the variable explorer on the top, you'll see that a is now 5 and is an integer. So anything that's run in this window will also kind of, if it's setting variables, it'll show up on that top window. If you, for example, clear everything that's in that window, and then you can't see what you've written before, you can click on that history tab on the very, very bottom. And you can see all the ones that at least we've run. You might only have 2 commands on there, but we have been practicing a little bit on this workshop account. So that's why you will see a little bit more commands run. Let's see. So the other thing that we can do with the left-hand side is we can type in that a = 5 and do a lot more commands in temp.py. And I guess for simplicity's sake, so that way we're not setting it to the same value, we'll change it to a = 6. And what we'll do is we'll save this temp.py using that either the save button or file save. And then we can click that green arrow on top to run that within that same console window. So it'll automatically populate the content of running that file into the console window. And now you'll see that a is now 6. So what we'll be doing today is we'll be creating multiple Python files and then running those in tandem to get things populated not only in the variable explorer, but also in plots. And I think that's it, unless I think the last bit before we shift back into PowerPoint is how to we have been able to open our .csv file, so an already pre-existing file, and we're able to edit a file that's there and save it. If you want to open a new file, you can either click File, New, New File, and then click it, and it'll have It'll just open as untitled.py. And then when you go in, you can save as opposed to save, and then you can rename this. And we'll be doing this for our practice here, and we'll start with main.py will be the first file that we'll use. So that's a lot to talk about for Spider. Are there any questions on the interface layout that we haven't covered? Any from online? Okay. All right. Okay. Okay, so we got our A to B where we start with the input CSV and then we want to plot the data into those two different examples as a pie chart and as a bar graph. And so we're going to go through each of those incremental steps, and those should be customizable depending on the data that you're putting it into. But we'll kind of set up that template for you in this workshop. So, so as you can see, this is our very, I guess, raw data CSV. What we want to do is extract only the columns that we need, and then save this data to a new CSV so we know what columns we're working with in this new CSV, which will be our like semi-cleaned in process CSV, and we'll clean that data in the new CSV, and then once we've cleaned it up, we can then plot it as numbers. So I think that's it, right? Yeah.
Okay, thank you. Yeah, so to create this project, we're gonna have multiple files working together. The first one of this we already created, which is main.py, and this will actually put our functions together in one single space and run them through. The other ones, which are CSV functions and plus functions, will contain functions that will import into main, but we'll develop the code for these functions there and then import the functions into the main file. Okay, so CSV will have functions dealing with data input, so load the file, change the columns, clean the data, those functions will be in there. The functions to actually make the plots once the data frames are clean and ready to go will go into plot function. So we'll have a function that makes the pie graph and a function that makes the bar graph that you want at the end. Okay, so those are the two functions that will go in there. And then the other file that you have is the CSV 2024 population file. That's already in there populated for you. Okay, any questions till now? Okay, so now for the rest of the next hour we'll go straight into Spider and just be dealing with the code. Okay, we'll come back. So give me a minute here. Okay. So for the main.py, the first thing we're gonna do is write the sections of how we want to do the code, right? So we have the A to B, which is we import that file, and the final result is that we want to do the two plots. Right, so that first step, we're actually gonna do this by comments. We wanna outline what we wanna do, and this is just good practice for when you have a big project and we're terming this big, right? So you can have steps on how to do this. So the first one is that we wanna import it. The second section is that we wanna clean it up, clean that data that we import and divide out. And then the last section is that we wanna create the plots, right? And that way we can organize our functions to fit into these three little sections. Okay. So now we'll actually go and talk about the functions themselves. So the first thing we're gonna do is import the data. So we're gonna go import pandas so we can use the pandas library. Anybody has used pandas before or knows what it is? Okay, so pretty common data science library or just general library to use. And we're gonna import pandas as PD. Okay. And then we're gonna use the pd.readCSV method to import that CSV into your code. So we're gonna go data equals pd dot read underscore CSV. Okay, and then we're gonna do the name of that CSV as a string inside of it. Okay, so that was a 2024 underscore population.csv. Okay, so that is the CSV we're reading it. And once that is done, it will come out as a data frame. Okay, so that data is now a variable that contains a data frame, and once we run this code, you'll see it populate over in the variable side. So we can go ahead and save that main.py of there and then run it. You see that it was not able to find the CSV file, which means that we gotta think about what we wrote. It's about the same.
You're
Think
in the
about
wrong,
using the,
you're in
what,
the wrong directory.
check files on there. Well, okay,
You're in the wrong path, if you see that.
yeah, there we go. Okay, now we do it again. Thank you, Paul.
Main apply is in the wrong folder.
Okay,
Okay, so we'll recreate, we'll save it as, put it where it needs to go. And you run it. Don't worry about it. And, there we go. So now we should see in the variable explorer the data frame, and it'll tell you the size of it. It should have a 216 rows and it should have 11 columns. Everybody had no trouble getting this to work on their side?
Where
Okay.
did you save it again?
so yeah, so we saved it here in our home directory, so home workshop.
And whatever the number of that workshop is. The default should be that you should land in the correct directory, so if you had any mistakes, let us know.
That one?
Yeah.
Didn't happen yet.
Okay.
Is anyone else experiencing errors? We do have people that can walk around.
Thank you.
All good? That's okay. Yes. Yeah, as long as know when you have the data frame on there, so you can move to. Huh? Oh,
You probably want to say if you made that file, the thing that is fine. When you save, you see that the path of the content. So you want to file. The arrow. That's fine. You can do what was that. You can save it as made up.
I don't know. Let's try. Oh, there we go.
Yeah.
Always working directories. It's like my Achilles heel. I told you, like, is your working directory in the right place?
I have my Achilles
Okay, seems that we got it working for most of y'all. Sorry for that one. Since we haven't, even though we tested this a couple hundred times. Okay, so now we're actually gonna go back to. Here in main, we're gonna write what our next function is gonna be, which is, so we're gonna write the function call before we write the actual definition of the function, just so you know what's coming next, okay? So the next one is gonna be called extract columns. Extract columns to CSV, because we only want two columns, right? We only want the country and the population to create those plots. So that's gonna be the name of the function, and the arguments are gonna be data, which is our data frame. And then comma is gonna be a list of the columns that we wanna take out. So we're just gonna create a list afterwards and put the name of each one, which is country and 2023 underscore population. Those are the two columns that we wanna take out of there. Right, and then in their case sensitive, so make sure that you have, that it's not a capital P or or capital C either. And then at the end, we're just gonna say the name of the CSV that we wanna write this to. In this case, we're just using short CSV. This is not good nomenclature practice or documentation practice, but we're just gonna keep it simple for today. So this is how your functions should look before we ever go to write that the actual code of that function. Right now, if we were to run this, nothing would happen, because this function is not defined at the moment, right? There's nothing telling it to actually use this function. It would just say, no, we cannot find this function, or you haven't defined it, okay? So to make this, we're actually gonna create the next file, so go up top and do the same process we did last time, which is creating a new file up there on file. And it will open again an untitled one.py file, okay? And we're gonna rename that file by saving it as CSV functions, right? So this is where we're gonna be doing most of our work for the CSV functions that we're making. Okay. We're gonna save it.
And then like we did before, make sure the directory is the same as main.
Yeah. Make sure you're saving it in your working directory and see that you have main and CSV in the same place. If you don't see main and CSV, don't save it there, because that means you're in the wrong folder, okay? Okay, so once you save it, you will see that the name will change up there in the tab. It will say CSV functions.py right next to your main py. And you should see it come up. It should say when it was created and who is the author, in this case, your workshop account number. Okay, now here's where we're actually gonna write the actual function. The first thing that we gotta do is create a definition statement, so we write DEF, and that tells it that a function definition is coming afterwards. Okay, and we write the same name, right? Extract columns to CSV, make sure that the name is exactly the same as the name that you use, you copy paste it from the main py file. And then we're gonna do the arguments. Now, in the other place, we use the specific arguments we wanna feed. Here, we're creating the argument, the general arguments that will accept anything else we put into the function, okay? So we need to put data frame, and that is the variable that's gonna feed the data frame in. The column list, which is the next variable, please remember to put the comma in there. And then, this is new, we can add colon and specify which type of variable I wanna put in there. I can say int for integers, I can say str for strings, or I can say list to make it a list. So that way the function will know to only accept that input as valid. So we define column list as list, and then the last part is name of the CSV or file or output CSV, and we're gonna define it as str. Okay, so those are our three arguments: data frame, column list defined as a list, and output CSV defined as a string, because that name comes in as a string. Okay, are we good till there? All the arguments? Okay, now at the end of this, we're gonna add this colon right here. And this is gonna tell you that everything after this is gonna be what the actual function performs. Okay, now once we're there, you're gonna go ahead and enter, and it's gonna create a tab for you. And here we're gonna define a new data frame, right? So we're gonna say new, first, before we start writing, we're gonna write in comments what we wanna do in this function. The first thing we wanna do is define a new data frame that takes out the columns. That takes out the columns as like the column list, it's gonna take those two columns out, right? And then the second part is to take those two columns and take that data frame and put it into a CSV. Right. So those are the two parts of this. So now we actually write the code. So it's good practice to know what you're gonna do before you do it. New underscore data frame equals data frame. And we're gonna go and use the square brackets to take out the column list. Right? And if you've used pandas before, you know that if you use square brackets and put a column name in there, it will give you back those columns, right? The entire data inside those columns. So once you have that, we can actually use a pandas method that already comes in and do, actually, before this, we had to import pandas up top. So before the function itself, remember to also write import pandas here. My bad, I forgot that, because now you won't be able to use any pandas methods in the functions itself. So this is the same thing as we did in main as well. Okay, didn't lose you there, sorry for the backtracking. All good? Okay, so now we go to creating the output to CSV. So we go new data frame dot, and that creates a two CSV method. So two underscore CSV, and that's a built-in pandas method. And we put in parentheses the name of the file that we want to use. So in this case, output underscore CSV, and we're gonna add comma index equals false. Okay. And what this does is that it doesn't add the indexing for that file. right? It takes out the columns as they are, and that way we can reuse the column list names later, okay? But keep that index files there and then the output name. Now remember, here we don't use the actual name of the CSV, we just use the variable that we defined up top. Okay, any questions till now? So our function is done, right? That is our first function all the way together. We don't have to do anything else for it to work or to close it, right? Once these two lines are written, we can go ahead and run the file itself. You'll see it runs, it tells you 9, there should be no output in this, right? Because this function is not being used, it's being written and defined. So now we'll actually go import the function into the main py file. Okay, and after the import panda statement, we will go import. No, we'll go from CSV underscore functions. Import. And then the name of the function itself we want to import, which is extract, and it will supply you the name if you got it right. Okay, if you write the CSV functions correctly, it should supply you the name on the import statement. Okay, so by now this is a valid function now. Please check that your arguments make sense. 3 arguments, and it should match the 3 arguments that we created in the definition of the function. And now we're able to actually run this all the way through. Alright, so. Actually, once did you save it? No, it shouldn't matter. Okay, so you would see that we got the name wrong by creating population instead of populations instead of population. So that's why it's out of the case sensitive stuff. Don't worry, that happens. So we rerun it again. And you'll see that this time it should be all good. Unless it says, yeah, it should be all good. It may give you a warning that it reloaded the modules, but it should be fine. And now we have, you should see the file short CSV pop up in your file. So we check files over there. We go down. There we go. So right next to main, you see short CSV pop up, and we can actually click on it and make sure that we have what we wanted, and we have the country, list of countries, 2022 population, and all the populations. Okay, and this actually we're gonna take a stop, and we're gonna go around and check if everybody's there, and we got to the short CSV. If we did not get there, we have time to fix the functions until we do. Okay, we're gonna take about 3 to 5 minutes.
Can you show us where the
Yeah.
root file is, cause ours is just a list of a bunch of folders.
Which one? Sorry?
So like it didn't pop up to show like the short CSV or the CSV functions, it's just a bunch of, it's like a folder with a caret, and then if you scroll down, it's a bunch of other folders.
Okay, so you can change your folders up top by clicking on the drop down arrow on there and going down to workshop 50. Instead of workshop 50 config, if you click on workshop 50, you should see the folders now.
You were in slash.
Okay.
There you go. They go all the way back.
Yeah, you see the short CSV?
Okay.
Okay.
If you click
Go
on that,
around a minute.
if you double click on it, it'll open here.
Does anyone want like main.py on the screen or CSV functions py on the screen to copy anything?
Yeah. Something in this, because it's all these.
needs to be-
Oh, there we go.
Yeah.
This is 22.
Yeah,
Yeah.
and the.
Especially on the-
The field is 2023.
Yeah.
Like the whole name.
So it's the main
So in your
Yeah.
main.py, it just shows it's all
Okay.
This.
And that's
So
what-
you check your CSV functions.
yes, this is.
Have you saved? Says something is wrong with this. It says the new data frame is not defined. Like, what are all these? Why are these?
Go ahead and close.
Try the. Like, all of this is not running.
Oh, did you?
Yes.
So did they look in squares? So this is 2 underscore CSV.
Oh,
Yeah. So go back to the CSV.
I can want to set the dash.
And then 2 underscore CSV.
So go ahead and rerun that. And then rerun.
Like, do I need to have a space here?
So save this one again.
Should this be,
Like, because it's not running. Yeah. Not
that one ran.
Yeah, so now it's finished.
Run that one.
but it's not defined.
So now we should have a short.
No, if you scroll down here.
Like this is saying.
Okay. Of course. Question?
Oh.
Yeah.
I can't see.
Okay, so you're gonna save it with the dot I think neither of those are.
Yeah, I know, it's the dark,
Such a really.
So that's
Yeah,
what it's
and then
supposed to say.
So, yes.
Okay.
Save main dot. And then resave that.
Or the comments. This is just tiny details.
I think so, yeah. So, right? No, it's all
Okay.
good, so.
Main dot pi again, in case anybody wants the reference.
So check, I would check your
All good?
files, and so you have a short.
Yeah, and she short CSV.
yeah.
So it should
Save
be-
them. Can you save that?
We're all good here?
So. And then. Go back to that little, yeah, and then click on working. And then-
You have any questions online? All good? All good. Also, don't worry about the back and forth, it's normal, this is meant to be more of a workshop than an actual lecture, so we'll be stopping a few times to see that progress is going as it should be, okay?
No.
Somewhere. Scroll down. There should be-
Yeah.
Yeah, this is like what I really.
So if you go all the way down.
Give me the data.
There you go.
We're good. Okay. Okay, it seems that we're good, so we'll move on to section 2 of the project. So now we have a short CSV, right, but we have no way to interact with that data. Okay, so we're gonna load that CSV back in. Okay, so in that next one, we're gonna use the same pd.read CSV function that we use up top. You can go ahead and copy that. And change the CSV name and also the variable itself. So this time we're gonna name it population data. Okay, just so we can differentiate between the two. And then we're gonna change obviously the CSV name to having loading in the short.csv file. And when you run this, it's gonna create another data frame that in this case will only have 2 columns, one with country names and one with population, okay? And this will make it much easier for us to clean the data and use it for plotting further along, okay? So once you run it, should be able to see completed there, and then go to variable explorer, and you should see population data, 216.2, which means number of rows, 216, 2 columns, and it should give you the country names there as country, it should give you the column names there as country and 2023 population. Okay, we're all good to now? Okay, so in section 2, we're gonna apply 2 transformations, and we're actually gonna comment this in before we write the functions. First one's gonna be to rename the columns. We're gonna change those column names. We're gonna change them from country to country with a capital C, and we're gonna change 2022 population to just population. Okay, this is just because most of the time you wanna manipulate data in columns at one time, so we're gonna teach you how to do that. And then that's gonna be the first function, change the column names. And the second change we wanna apply is to clean the numbers. Okay, so why do we wanna clean the numbers? Okay, so if we go back to the short CSV, what data type is that number? The number that is there right now? Do we know? No, it's a string, yes. So it's actually a string and it has commas. So if we wanted to right now use this for the ply, I wouldn't take it as a number. We gotta convert it into an integer. And then, well, we gotta take the commas out and then convert it into an integer, okay? So we're gonna develop a function that does both of those things at once. And this is really the power of functions, to be able to combine many actions in one go. And we're gonna take the commas out and then change it from strings to integers. Okay, so those are the next two functions that we're gonna write. Okay, can everybody see the writing down here, or do we need to roll it up?
Yeah,
Okay,
you can
we
see.
can. There we go. Very good. Yeah. Okay, so we're actually gonna do the same thing we did with extract columns. So we're gonna go ahead and write the actual code now and then go and develop the functions later. Okay, so for the column name ones, we're gonna do rename underscore columns. That's gonna be the name of the function. Then again, the parentheses and the arguments are gonna be population data is our new data frame. And then comma, the other argument is gonna be a list of what we want the new column names to be, which are country. Capital C. And the next one, which is population with a capital P. Okay, so that's pretty easy function, two arguments, and now we'll go to write it, but I wanna actually write the clean number ones too. Well, actually, no, let's go write rename columns and then we'll come back for the next function, okay? So we'll go back to CSV functions. When you have that main, don't run the main though, because it won't be able to find the function, it'll just give you a big error. So let's go to CSV. And then we'll write the next one, and again, we have to start with the definition statement, so actually go ahead and scroll down so they can see what's up. There we go, so we're just gonna define the next function. Okay, so same thing, you can copy paste the name that you already did, so definition, def, rename underscore columns, you can go ahead and copy it so you make sure that you don't miss any s's or any capitalization if you use any capitals. And then again, we gotta define general arguments for the function so we can reuse it. The first one's gonna be data frame, because that's what we're feeding it, a data frame. And the next one's gonna be, again, a column, a name list or a column list, whichever you wanna use. Yeah, new column names. And then that's a list, okay? Now, although we're making the name super explicit here, you can use abbreviations when developing your own functions, but for today's workshop, we're trying to make everything as clear as we can. And remember the semicolon, the colon at the end, okay? So it does that. Okay, so after this is done, we're gonna write the actual code, which is data frame dot columns. And what that does is that it takes out the column names, that's the pandas shorthand for getting out all your column names together. Yeah, and we're gonna go equals column names list, new column names. What do you use? Yeah, new column names, there we go. Right? So in pandas, when you take out dot columns, that is automatically a list. And what we're doing is saying this list, change it into this list. And if the name is the same, then it should be fine to port over. Okay, does that make sense? So at the end of this function, that's really the only line we need. Okay, to convert the column names from one to the other. And we're really doing this for organization purposes. If you have a single line of code, then you don't really need to chunk it out to a separate function, okay? But for this case, we're gonna keep it over here, and this should change your column names to what we want. So now we're gonna run CSV functions again to make sure that we load that function, and we're gonna go back to main. Okay, once we go back to main, we click on, well, before clicking on run, we have to import it, right? So let's go up to the top statement and remember to add right here. You should be able to just comma at the end of that one, actually. Yeah, we're able to comma and put the next one. So the next one is rename underscore column, right? And this way we tell it that we're importing a new function from that same module file that we have. We don't have to create a separate import statement, and now we can just go ahead and run main py. And we use that capital letter, there we go, so we take it out, write it again. There we go. So we should now see that the column names on population data have changed, the column names are now country and population. Okay, and I'm gonna take a stop here before we do the clean numbers function, just to make sure that everybody gets there, okay? And if you see us doing errors, half are on purpose and half are not, it just teaches you to actually look through your code pretty intensely to find those little small things like square brackets or curly brackets or capitalization that tends to fall true when you're writing code, okay? Give me a minute there, everybody, okay? Come down, okay, we're gonna take 2 or 3 minutes and we'll go around, take over that.
That one just a one.
No, I think you're-
Not like
you
the
rewrite
CSU
CSV.
function, CSU function is the highest.
So just
Okay,
let that
but
file.
it's not a, I know it's a red, but it's just, okay, yeah.
I know you
Okay.
can change that, but it's always so scary.
Right.
Like terminal and R, like all these things back in red,
Okay.
like, stop.
Yeah, actually, so if you wanted to see,
Oh, yeah.
so I would say, yeah, tell that, and then click that same. Yeah, that way you see the file.
There we go.
Yeah.
Yeah, yeah, my Bible folder keeps reloading.
So you're like, all in your box. Yeah.
Sweet.
Okay. Definition, you have to have it. So we're gonna do that, because now it's considered this as part of this. Yeah. Yeah, this is everything. You'll go check your font is right now. Yeah. You got it. Okay, we're all good now. So the next function, as we said, was gonna be the clean numbers. So we're gonna name it the same thing. We're gonna name it clean numbers. We're gonna, yeah, let's keep adding actually add the underscore just because we've been using it for everything else. There we go. So, and then we're gonna feed in the same data frame. So we feed in population data. And then comma, and we feed in the name of the column that we want to change the values on, in this case, just population, right? So those are 2 arguments, one of them is a data frame, and the other argument is just a string of the name of a column, right? We're not applying this to multiple columns. If you ever wanted to change this function to do multiple columns, you just do what we did above, right? And apply a list instead of a string, but in this case, we just want to change population. Okay, so we'll go back to CSV function and we're gonna write this new function. Okay, so we create another definition statement. Go ahead and do enter, def, the name of the function, clean underscore numbers, and then the 2 arguments. First one is data frame. Second one is gonna be column name. Okay, and that is gonna be, instead of a list, this time is gonna be a string. And we define string by str. Okay. So those are our 2 arguments that we're gonna be using. And then remember the colon at the end, right? And we go ahead and create the code. So let's sketch this out. The first step is gonna be to eliminate the commas, right? The second step is gonna convert from strings to integers, okay? So these are the 2 actions that we're combining in this. So for that first one, we're gonna do the same thing that we did above, but reference a single column, so it's gonna be data frame. Square brackets, remember the square brackets here to reference a column, and we put column name in there. So this will take out that population column that we have. Okay, and we will make it equal. Data frame column, again, the column name. So we go data frame, yeah, and the same thing, square brackets, column name. And now we're gonna use a method to change the commas. We're gonna use .str .replace. Okay, half the battle is knowing which method to use to make your life easier. Okay, so now that we know this, we're gonna replace the commas, and this we do by defining a string with a single comma. So that's string opening up top and a comma below, and then just defining the next one as just an open string. Okay, so that's gonna give you. Yeah, that's gonna give you the changing the commas to there being no character there. Okay, so the first character says which character do I wanna change? And the next one is which character do I replace it with? We can replace it by dashes, replace it by spaces, but the goal here is to have no spaces and no dashes or commas between our numbers, okay? So, once that is done, everybody got that STR replaced, when done? Anybody want me to zoom in to that comma, no, bro, you can't zoom in a bit more, I don't know if it, with control and the plus. And you need to move it to the top. Next slide. Yeah. There we go, just so you can see the ending here. Okay, so you do a string, comma, and just a string with nothing in between, okay? And there. Okay. Now, the next one is gonna be the converting from string to integers. So the same thing, we're gonna reference the column with the same thing on top, you can copy paste it, data frame column name. Okay. Is gonna be equal to. The same thing again, data frame column name. And now we're gonna use a different method, which is dot as type int. Right, and this will change the type of the elements within that column. Okay, so that is telling it to change everything in there, which is right now a string, into an integer. And if it is numbers, there should be no trouble. If the number is too big or in a different scientific notation, then it will try to do a float and it won't be able to, so keep it as int here, okay? So that is the clean numbers function. We're all good there? So we're gonna run the CSV functions file again, okay? And then we're gonna go back into main, make sure that it is written the correct way, make sure that you match your arguments, that it is data frame and it is that column name, a single column name, and that you did not use the list. And now we're gonna import it again, so we go comma and add the next name, so it's gonna be clean underscore numbers. And then we're gonna rerun main py. Okay, there we go, so now when we see it, we should see if we click on population data, that now it is actual integers on there. Okay, it is, there's no commas anymore, and you should see in Spider it populates with these like really nice background colors. Which is, we think it's a scale of trying to do the numbers, but if not, you should just see that it's just numbers, no commas, okay? And we're gonna take a little break here, make sure everybody is on this page before we continue on to the rest of the rest of the fund.
You go back to the.
Oh, you're good. Let me see that. So it's not reflecting that it's not. It says there's no comma with no space under it. And yeah, we're gonna rerun the CSV function. Okay, perfect.
It's used for saying keyword.
And so when we're basically like we're doing manipulations on that.
Oh, did you?
And that's why we're. And we're just doing a general, because we're in a function. Yeah,
Okay.
does that make sense, or does that not answer your question?
No, it makes sense.
Okay, I guess, yeah. The data frame is just like a pandas variables that makes it really easy, to like, manipulate CSV, like file contents.
Okay.
Yeah. So it's like a native thing within pandas have. But it's just like polygon stuff instead of just like typing in.
Okay, okay.
Yeah.
What's the example word you were parsing?
So you could technically close like lines of CSV functions as strings and just like, oh, but like after like the fifth comma, like this is about.
I mean, it's missing.
But data frames has like, I want the columns, I want the rows, I want the.
Yeah.
Trying to think what else, but yeah, so data frame is just like a variable.
stuff.
Yeah.
but
It's
especially
yeah.
and it ran correctly, like it's successful. And I added it to the list of functions to import. I don't understand. I need help. Why does it say that I'm missing one required positional argument column name?
Let's see, so you have two sets of parentheses and then one set of parentheses.
Okay.
Yeah.
What's this?
Mhm. Yeah, so basically when you put it in like the parentheses, it's kind of similar to how we did it with the square bracket thing there, where it counts as like one value.
Okay.
And then like, so like, it's technically called a tuple, is what that is, but, yeah, so technically it's like, oh, three numbers, we've gotten one value, and we need like the second one.
Was I? Yeah. That's such a. I get this. I was trying to sell a copy of the slides from the data. This.
Well, yeah, so have to-
The only difference is the return, but it shouldn't affect it.
Because that's the only thing, yes, I
Yeah, but
don't,
it's-
I
but
don't
it
know,
shouldn't.
know it again.
Yeah, but it shouldn't.
So go to your.
No, check it. Yeah. Okay.
So for reading columns, is that?
Okay. I wasn't told you, it's not, I don't know what I'm trying to do.
No, it's written.
I'm just a spectator.
I know.
So dataframe. Oh, okay, yeah, so it's not changing. And then S.
She's gonna be the fun one. So
Okay.
this is the code that you write this into this.
I thought Marcelina was coding on the spot.
She'll call in this spot, but just in case she's.
Now it's different.
I know she gets excited like me.
So.
Yeah.
Thank you.
You're welcome. Right, your turn.
Okay, so we are done with the clean data part of the function, right? So we have done, at this point, you should have just a population data frame with two columns, one country, one population. And the population one should be all strings, no commas, okay? So once that all is done, now we're gonna move into the actual plotting, right? And this part I'll pass it to Marcelina, so she can do the two plots. But yeah, that'll be all.
Why is he not typing?
Oh, you can, you wanna type?
That's okay.
Oh, no, he has to go. Yeah. Okay, so. We start off, yeah, we're gonna start off in main and we're gonna do our comments again, where we start off with, create underscore, or so we're gonna create a pie chart and then we're gonna create a bar chart. And those are our two, spots for plotting. So we'll do our comments first to kind of outline, like, this is what we're doing. We're plotting a pie chart and then we are, also gonna plot a bar chart. So we'll do create pie chart first, and that's gonna be, create underscore pie underscore chart. And then in our arguments, we're gonna do population data, and so we're just gonna take that data frame that we've been working with. Can you, like scroll up or like click enter below so that it's a little bit higher? So, yeah, so now that we have both the numbers, and the, country names, then we can create the pie chart. So we will actually create a new Python file now. So go to File, New, and then that untitled.2 will open, and then when you click Save, it'll allow you to rename it. And then you can rename this plot underscore functions. And then again, make sure that it's in that correct working directory that you can see the main.py, the short CSV, the CSV underscore functions, and then we can save. So for this one, we want to start with the create underscore pie underscore chart definition file or definition function. So we take that same format that we have, we simplify this. Instead of doing population data specifically, we'll do data frame. And then we'll put a def in front of it since we're defining this function. And then we'll end it with a colon. So the other thing that we want to do, since we are still using data frames, is make sure that we import pandas as PD. And then we should be good to go and start off there.
I know it's late. What
Yeah.
is the, when you say as PD, what is that?
Mhm.
What does that do?
So, right, no, that's a good question. So, you can import packages just as they're, just as they are, so pandas, but then, when you're pulling, when you are pulling functions from that specific package, you will have to do pandas dot, whatever.
Whatever.
Right. So if you do as PD, then you can kind of like use it as like a shorter version of that and do just PD dot whatever that function is.
So it's like, I'm used to R, it's like
Mhm.
you use the library load function.
Right,
That way you don't have to just do pan, like.
right. So then it would be like
pandas
lib
call
dot,
every time,
yeah, right. So for example,
Yeah.
we'll import another one, which is a lot longer. Specifically for plotting, we use the matplotlib library. So once we'll go back up to the import statements and do import matplotlib.pyplot. So that's like a specific sub-library of matplotlib, and we'll do it as PLT. So that way, when we're calling any function from that, we'll just do PLT dot whatever. Yeah, so, and this is a lot of typing and talking and typing. So for, and I know that we weren't able to do in our Python bootcamp anything with plotting, but plotting itself is very simple. You only need really 3 pieces of information to create a very simplified graph. But the problem with that is there's like absolutely no other information. When you do that, you only get the graph and the data. There's no title, there's no like X label for the X-axis or a Y label for the Y-axis. And so we'll start with that simplified version, run it, and then when we go to the bar chart, kind of like go through all of the different spots for making the graph. So, not the rails. Where are you going? So this is the main, like, creating the pie chart for the population data. So it'll be plt.py, open parentheses, data frame, square bracket, population, and that'll be how you produce a pie chart with the population data. Before we do that, though, we want to set up that plotting space.
This will be minimal.
Yeah, well, we can, so we have to set up that plotting space to do plt.figure right before that. So we have a space to put our graph. So plt.figure, and then you'll have the opening close parentheses. And in this like figure command, you can set up a couple different parameters, and one of them is the figure size, and so you can do those manual adjustments in here. And the reason that we're doing 10 by 6 is because when it the default size of it is just ginormous. And so we want to make sure that it fits in that plot window and that things are readable. So we'll set the figure size to 10,6. And so the three commands that you really need to get started on that is the dot figure, the dot pie, and the dot show. And this is the same for any of the different charts that you use. It's whatever that the main parameters of that chart is that middle command, and then you start with a figure and then you end with the dot show. Yeah, so what you can do is you can save that under plot functions, but when you run it in main.py, since we haven't imported the plot functions Python file, it won't produce anything.
Yeah.
So we'll do that now. We'll from plot underscore functions, we'll import create pie chart. So now when we go and we run it, we'll run into an error because we have an extra parentheses in that function call. So once we correct that and we run it again, we'll have this beautiful pie chart. And you can kind of resize that window by playing with the rest of the windows in that space, or you can click that zoom button up top that has like the 50% next to it. And so that's like the basics of creating a plot, but in terms of all the information that we have for this is not super helpful. We just know that there's one orange set that is larger than the rest, and then it gets increasingly smaller as you go. So to make this a little bit more useful, let's add some extra labels. So what we can do is we can label each of the sections of the pie chart based on the country name that is that first column that we have. And the way that we do that is in that pie function call, we would set label equals data frame square brackets country. The other features of this, there's a lot of different features. So as you go through the documentation, you can kind of see every single argument that you can include with the pie call. But we add the auto percent formatting to make it look a little bit nicer, and then that start angle is 140. So once you add these in, so auto PCT, and then it's percent 1.1 F and then 2%. And so this is just a funky Python way of formatting things as F string.
It's a float with one digit behind the dot. So not 5.2.5, but 5.3.
Yeah, so basically this allows you to like read how much of that percentage is that pie graph of each of the populations, country populations in the world. And yeah, as you can see, the way that it's kind of set up too is that the start angle starts at that like 0 line if you like go and do the 360, so it starts pointing, I guess, to the right. What this start angle will do is it'll shift it upwards, so that it just looks a little bit better. So when we do that, we can actually see the changes for that before we start adding anything else.
Very.
So yeah, so sometimes when it gives you that error, data frame is not defined, it might be a typo somewhere in, it would just look for where that's occurring.
We got an error for the label.
Okay, is it data frame, did you capitalize your F for data frame?
No.
It's saying that the pi function got an unexpected keyword argument called label.
Is anyone else experiencing the? I mean, if it is the spaces, then we're good.
Yeah.
I think it needs an S
Yeah.
Oh, labels.
according to the documentation.
Okay.
So did it run for them?
Bulk.
I have no idea.
Can you change, scroll? And.
Well, I don't know what the hell is this.
Oh, no, it's
So
there.
you need to, add in a percentage after.
What?
It needs to be an after.
Yeah,
And then
either way,
first
just,
10%.
when you run it on
I wish they would zoom in on this. I can't see.
Are you getting the labels?
So for those that, or I guess for those online as opposed to home, we typed in label as opposed to labels with two, with an S, multiple labels. I don't know. Yeah, I can put the rest of that.
It's because the size is so small.
So, yeah, so the, yeah, so, so this is why we're doing two different plots of it. This is a little bit more helpful, there's a lot more information, but, it gets a lot less readable. A way that we can combat this is changing the different formats of the charts that we do and the graphs that we do. And so that's why we're also doing a bar chart. So maybe, just because we can do it in a particular graph doesn't mean we should do it. Example A.
So the out of percentage is this thing. 18.
Yeah. Yeah, so actually what we can do is, so like Paul said, the auto percent, make sure that you only see the first decimal point number and not all of the rest. So if you actually remove this, this part here, where you remove the auto percent argument from this, and then run it again, you'll see that it's even messier than, what we could hope for.
No, it doesn't do anything.
Okay, so yeah, so that's another, added aspect of it is making sure that, when we add the percent, we can add more information to that graph. So Paul's adding 1.5 to see if, to see 5 decimal places after the decimal point. And so you can see it gets super specific, especially since we're dividing by 100, or like the sum of all of the populations that we have. And so 1.1 kind of makes it a little bit easier to read. So any questions?
Could you have that made again for a second?
Go to me.
Can you scroll?
Is anyone experiencing issues?
Yeah. Yeah. Other countries.
India, China, other countries.
And then go to files. And then go to.
I didn't find this flow and I didn't see it was some. Okay, it's
I found it.
at the back here, after the 0.1, there should be an F%. And then the percent. Yeah.
I missed the percent. Yeah.
Oh, okay, you have to save it as a document.
I really wish they was.
Yeah, I can't see it now.
And that's just.
It's always something.
Or the start on the display, the projector.
So label. The name. There you go.
Oh, yeah.
Any questions from online?
Oh, that's right, yeah.
Questions? We're doing good. Okay. Okay, so to add just a little bit more to our pie chart, we can add a title to it, and then what is field to access? Can you run it already?
Yes.
So what does it look like? So yeah, so go back. Yeah, so go back to the code. Please. Go back to the top. So yeah, so the other two things that we can add to this pie chart is the title, so plt.title, and then plt.access equal. Which so for this one, I believe this is if the percentages are not equal, then or the percentages are equal to another thing on there, it doesn't display it.
What is the equal function doing?
That's the difference between these two. I don't know.
Yeah.
This is without, this is with equal.
So it just kind of looks like the sides are shortened. So that the, yeah.
Change like the aspect.
Yeah. Okay, how are we doing on time? Okay.
¼
Yeah, so the last graph that we'll do is gonna be the top 10 bar chart. So this will at least allow us to see what the top 10 populations are. And the way that we'll do that is top 10 bar chart parentheses population data again. And then we'll put that in our plot functions as top def, top 10 bar chart parentheses data frame.
Yeah.
And we'll also add it to our plot functions import statement on the top of main for ease of use. And so for this, it's the same deal. What we want to do is we can so we can do the plot figure and then plot bar and the plot show. But that will just give us the first 10 on the list. If we want to make sure that we have the top 10, can you scroll up? Enter a bunch. If you want to make sure that you're actually getting the top 10 values, even if your data is unsorted, there is a data frame dot sort values that allows you to sort them by population, and ascending is false. So that way it'll start from the largest and then work its way down. What this is doing is it's setting those top 10 to a separate data frame outside of the ones that we have. So that way it's not putting in any of the other populations. It's not putting any of the other populations that we have. So this is a long data call. You can do that. Verso ascending is the second one. So yeah, so after we do the sort values, there's the dot head. So head will only pull the top 10 from that sorting values data frames. So it would be this dot head and then the top 10 ones. So same format as last time, plt dot figure. You're gonna do your next one, yeah.
So does it normally just do it in ascending order? So we're saying false to make it descending?
Descending, yeah. So it'll start the smallest and then work its way for the auto sort. So it's plt figure, plt dot bar is the actually plotting the bar graph, and then plt dot show is that last one. So when we're doing plt dot bar, because pi just plots the actual numbers and then we can include the labels. The way that the format for bar works is that we're doing the x values first on the x-axis and then the y values. And then from this little pop-up, you can see there's a bunch of different options that you can add to it. But we're just adding color to it so that we know what color it looks like. And then we can add the same thing that we did before where we add title. Because pie charts don't have X and Y axes, you don't need X and Y labels. But for bar charts, when you want to do an X label or a Y label, it counts as a different command. Let me scroll up again, Paul. So, well, and then we'll just do show, right? So as to not complicate it. And then as we're looking through this as well. From line 24, our data frame should be with a capital F. Because we're referencing the one that's coming in from the arguments. And yeah, so that's our top 10 bar chart function.
You have.
All right, so for those that were on the, for those that were online, we're going through the plot functions. Python, where we were, oh. Did everyone get all of the definition of the function before we shifted? Okay. Can you go back to the plot function? And then, so yeah, so if you have this already written out, you can save this and then run that code in the main function and you'll get a bar graph. So raise your hand if you're having any issues or if we lost you with it. Yeah. So go back to the plot function. Yeah. When you define the bar chart, it should have like a capacity close parentheses data. And then so, yeah, so enter. And then have that like, you need that this one, somebody gave, but, machine, so, I see what's happening, so actually back to the contribution, that should be its own, she's gonna, so she's.
Well, yeah, that's why I asked.
And then so,
No, the
Oh,
problem
okay.
is she did that engineering. So she makes them. But we're.
Oh, good question. So once we change this.
Yeah.
Which is great.
You're not supposed to. Grad students are poor.
Oh.
I don't know why they have to bring food.
so you can save it as a file here.
Oh, okay.
And save the, yeah, save the figure, but, also, we also offer Jupyter notebook that kind of like incorporate most of the code and the graphs. And then you can export that as a PDF and like have both of those along with like your comments and like paragraph.
Oh, okay.
Yeah.
Thank you.
Can I look at, here's your name again?
Well, so create font.
Oh, yeah, there's a different problem.
Okay, so create pie chart and you can roll up. Yeah, so this is now happening on that screen, so close the indent.
Okay.
Last time I got it done was the first time I passed out, or maybe the second time.
And then page stops like clip. I think you can just like
I
highlight
have
and
a
then
phobia, it's just the, taking it out of me, it like, my dad has it too, he doesn't have a mutant either, it's just a.
Yeah, the blood injury injection. Well, my dad and my brother.
like up,
So like, my brother.
Yeah.
Talked about his surgery.
No,
I think we
yeah,
just-
I
we just-
can't talk about it, great. Okay.
It's the. Yeah.
Okay. So yeah, does anyone have any questions outside of that? With plotting, without plotting, about anything that we learned? Any questions online either? Okay, so those are effectively ways that you can have, like multiple different functions, organized in different files that you can pull, just like you would pull packages packages and other libraries. We've created a new CSV. We've made extra plots. If you'd like, in that plot window, there's also a save button, so you can save those plots as JPEGs or PNGs. Right now, they're just populating in here, so if you close, you would have to rerun the code to generate those again. But in the top left corner, there's a little save button that would allow you to save it, as well as right-clicking on it. And then again, just making sure that you know where you're saving it, so this is in the home directory, and it automatically just generates extra metadata in that text. So, before we do our wrap-up, are there any questions about Spider, plotting, functions?
How are you getting plot window? Into each one?
So yeah, so good.
So if you have a plot here like this, you click undock. And then you click like this.
Yeah. Then you can dock it in. So there's a lot of functionalities with Spider that we didn't explore. I mean, we did only have an hour and a half. So if you are interested in using Spider, you will be able to use these workshop accounts for the next 2 weeks before we have our next workshop. And you can explore it, or you can also create an RCC account to be able to work on your own RCC account Spider environment. So can you shift back to the slides? Yeah, and then, yeah, so that's the wrap up. Full screen? Slideshow. So, so we didn't go into this at all either as we were going through this because we all just wanted it to be in that same folder. When you're creating a like multi-file structure for code and for projects, it's helpful to kind of organize things into different folders. The only thing that would change when it comes to those commands that you've been using is just to make sure that you follow those paths. So for example, like if your 2024 population CSV is in your data folder, then you just have to do data/2024 when it's calling that specific CSV folder. The other two that I recommend inside data is you can split it between your raw data versus your process data. So when we created that short.csv, that could go into a like semi-process data as opposed to the raw data that you have. Scripts is where your main.py can go. And then the SRC, so your source folder, is where the CSV function can go. And then plot functions as well. So when you're importing those in, just make sure that you know where they are and list them accordingly in their folders. Next. So we have a survey that will get distributed later on. We appreciate any feedback as this is our first time doing an intermediate Python workshop. I think in the history of RCC. So if you are all interested in putting your like how things went opinions now, we have the good? Okay. So you can either scan the QR code or it's that short link over there. You'll also be getting a link via email tomorrow. Yeah. So you're getting a link via email tomorrow for that same survey. So while thoughts are fresh, that's an option for you. We'll also send out slides, I believe, with that email later on.
Yeah, it says the survey is expired.
Oh, survey expired? Casey? Okay. Well, okay, so we'll get that fixed before we send it out. Thank you, though. And then lastly, our last slide is thank you all for coming and learning and joining us. we have one last workshop in spring 2024, dedicated to running things on the high performance computer using the Slurm job scheduler. This is a way, the way that you guys have been interacting with the high performance computer right now has been mainly interactive, where you're hands-on, like working on things as you're like in Spider or in Jupyter Notebooks. This Slurm job scheduler allows you to kind of get that like job is queued and then job is running. So it's an interactive way of working on the HPC. But we'll also be teaching how to non-interactively work with. So for example, if you have a Python file program that will take multiple days to run, and if you're gonna run it on your personal computer, it will just sit there for days and that'll be the only process that it runs on. Or you can submit it to the HPC and do the same thing that you would with your Spider environment, where you can kind of close it, come back to it, check on it within that given time frame. And we'll be talking about that within the next 3 weeks. And yeah. So if anyone has any questions, let me know. And I'll be happy to answer them. If not, within that window of this workshop right now, if you have any questions outside of that, feel free to email support at rcc.fsu.edu with questions. So yeah, thank you guys for coming.